Anaseo, Sol. Hello, everybody. Kamsahamnida. Thank you for coming to our Red Hat event. We very much appreciate your attendance. I understand that it's been a long afternoon, but we've got 2 more sessions to go, so hopefully we will keep you awake until then. I'm going to be speaking about storage in relation to containerized applications. So first I need to tell you a story that gets us to why we need to think about storage differently for containerized applications. So I want to begin by re-emphasizing the concept of DevOps. Now there are 3 players that we'd like to talk about inside the enterprise. The business side, which has a demand for responsiveness. They want change. They want things to happen very quickly. Then we have the developers. They just want to get their code out. They like to program, right? They need to get their applications into production as fast as possible. And finally, you have the operations team. All they want to do is keep things running. They want to keep the lights on, right? They want to make sure that everything continues to run smoothly and is not interrupted. And this is very important for all 3 to work together. And in the past, there have been lots of divisions that have prevented them from effectively working as well as they could. So what DevOps offers is the opportunity for better collaboration, better communication, and the ability for them to start to automate. If they can automate a lot of the processes that go through this, then the development cycle is more efficient, and then we can get more code out quicker. Make sense? That's the whole DevOps story that we like to talk about. And of course, there's lots of technologies that go into this, but the most exciting technology that we at Red Hat think is playing a part in improving the DevOps adoption within the enterprise is containers. So let's talk about containers a bit. There's perhaps not quite as good an understanding of containers relative to other technologies as we would like. So we would like to emphasize what containers really mean. Effectively, it's a software packaging. How can we get all the parts and components that are required to operate an application into a container that can be easily rolled out? If that container is used, we find that we get a more efficient and effective way of getting the software out quicker, more often, so there's an increased release cycle. If the release cycle is more efficient and quick, then we can change things more often. So we often talk about a feedback loop. If you can hear what your customers need, you can go back and fix it, and you can bring the next version out as quickly as possible. That brings about a quicker life cycle for the development of the application. This means also that we can improve the test cycles so that we can pick up bugs, pick up mistakes quicker. That's a good thing. The faster you can find out something that's wrong, the faster you can fix it. And of course, the best part about containers is the ability to manage those applications effectively once they go out into production. So let me give you a brief visual analogy to what I'm talking about here. If you think about the traditional old applications, you have a big server and you put big operating system onto it and you put all the application into it, right? Let's talk about that. Oh, this is the different deck. Okay. So if you think about the old application, you have everything on top of it on the one bare metal system, right? Now, with virtualization, this is slightly different. Now you can contain the application, the operating system, right? And the application and its libraries in one virtual machine. But this also allows the efficiency gain on the left there of having multiple virtual machines on the same system, right? Which is effective. That helps us a lot. But containers takes it even one step further. Now we get rid of all the unneeded components, right? So the application is running very, very lean. It's very lightweight. And by doing that, you can have multiple containers on the same system without the overhead of the hypervisor. If we get rid of the hypervisor, the applications actually run quicker, the performance is better, but also because they're lightweight, we can deploy them quicker and change them faster. Make sense? So that's the evolution from bare metal applications, virtualization, over to containers. In fact, we did a study on a very large application that was required to install in traditional sense on the bare metal side, and it might take 27 hours. That includes getting the machine together, switching it on, getting it configured, installing the application and the OS configured, 27 hours, right? We moved very quickly with virtualization to now maybe 12 minutes, which sounds fantastic. What a great improvement. You can deploy a new virtual machine in just 12 minutes. That same application can be deployed into production with a container in 10 seconds. So that's the massive decrease in time that can be improved there. Now with that comes the ability to scale the application much more dynamically, right? We talk often about granularity. Everyone heard that word applied here before? How granular can you make your application? We like to think of it this way. I would rather have my application be lots of small parts than a few big parts. Why? Because if one of those big parts fails, then the application is very affected. If you have lots and lots of small parts and just one of them goes away, it's not that big a deal. Make sense? So your application, if it's distributed between many, many servers across perhaps even multiple data centers and using lots of small containers, it's able to withstand the odd failure of one or two of those small containers. So the market dynamics that we've seen is you've seen this massive increase in the interest in containers, especially with Docker in the last year and a half, 2 years, evolving into much more recognition of the ability to everyone to actually containerize their applications. So they standardized, they brought a technology which was in fact 10 years old, and they standardized it in a way that everyone can now containerize their applications easily. So what has happened here is that we've now got a way to deploy the application much more efficiently, much more quickly, but it's not good enough to take the old applications and just simply bundle them into containers. We need to rethink the architecture. So the new architecture that we want to think about here is microservices, right? Microservices is really the ability for us to think about a different way of actually architecting, designing the application. I'm going to talk about food for a minute. Who likes pasta? Yeah? Italian food, right? Think of a bowl of spaghetti, right? A bowl of spaghetti. It's all in together, right? It's a whole big bowl of spaghetti. You can't take one piece out. It's a very nice bowl of spaghetti, but that's the traditional application architecture. It's all just in there in a lot of food all together in one bowl, right? Now, who's heard of lasagna? Yeah? Now make your mouth water, right? Lasagna has lots of layers, right? You put one layer down, you put some meat. You put another layer, you put some vegetables. That is the traditional tier, multi-tier application. If you take a slice of it for serving of lasagna, you get all the layers in it, right? But it's not really separable. You need to have all the layers to taste all the goodness from top to bottom. But now my favorite kind of pasta, ravioli. Who knows ravioli, yeah? Lots of little nuggets of pasta. Now why is that an analogy for microservices? Because each little piece of ravioli is a different service or a different component of the application. And you can take one of those components and scale it without changing all the other components. Does that make sense? So your microservices breaks down your applications into a bowl of ravioli, which is all swimming in the source. And the source is the storage. That's the persistent data which is shared by all the microservices. So that's the analogy to keep in mind. There's a lot of other different analogies here, but we want to compare the ability to take very few large parts, that's the old architecture, to very many small parts, the new architecture of microservices. And if you take that approach with the architecture, you have now the dynamic ability to scale your application much more quickly, much more rapidly. And this is actually what the developer really wants, because they don't have to think about, am I going to run out of memory? Am I going to run out of storage? Am I going to use up all my CPU too fast? They can instead design their application in a way that they design just their little piece of ravioli and they put it into the bowl with all the other pieces. So it can scale up and scaled out differently. Make sense? So that gives us that ability. Now Red Hat has really worked hard to make it as easy as possible for the developers to make those containers also safe and certified. So we have a program, a container development kit that enables you to make those containers and then make sure that they're certified. Now, why is it important for those containers to be certified? Because if you just download a VM or an application from the web, you don't know who wrote it, you don't know what's in it. But if you have a certified container, then you have more confidence to actually use that container in your enterprise and in your application. So Red Hat has also evolved a registry. And the registry allows us to submit those containers to a common repository where we can actually reliably know that those containers were written by a certain vendor. So look out for that when you're using containers technology. You want to make sure that you're using a reliable source. Where are you bringing your containers from? So the basic 3 levels that I'm going to go into from Red Hat's perspective. At the bottom, obviously, is the operating system. Every application needs an operating system to run. And Red Hat has worked very hard to optimize the operating system, which you all know, Red Hat Enterprise Linux, to a Red Hat Enterprise Linux Atomic Enterprise Platform. This is our lightweight operating system that is optimized to run containers. Remember back to the analogy of the big old machines, the smaller virtual machines, now the lightweight containers. We want the operating system to be as lightweight as possible. And that gives you the flexibility of using many more containers simultaneously in parallel. Once you've got that basic setup, that Atomic Enterprise Platform allows you to distribute your applications and then deploy them across many different instances, whether they're on different footprints of hardware. Above that is our OpenShift Enterprise Platform. This is our PaaS. This is our ability for the developer to actually build these containers. One of the important applications that we have for this is called source to image. It means that you can describe your application in a way that it's all in code, it's all checked in, so that you can actually take that code and rebuild your container very quickly. Remember back to the DevOps concept of operations and making it automated. If it's automated, it means that you can reliably recreate that same environment. Now for storage, this has traditionally relied on your operating system and your storage attached to it provided by the operations side. And you didn't know or have control over the storage that was attached to your application. But with this concept, you can actually describe your needs in the application manifest and actually have that application, when it's built into a container, request the storage that it needs. And I'll get into that in a second. On top of this, riding over this, is our latest product, Cloud Suite for Applications, which embodies all of the goodness of the infrastructure of OpenStack. And you heard my colleague Sukju explain earlier on about how that integrates with Red Hat Ceph for storage and OpenStack, as well as putting the whole development environment, OpenShift Enterprise, into it. So basically what we're saying is there's been an evolution. This is the story we've seen, an evolution of IT. First we had all the waterfall development, which adopted and embraced Agile, coming into the DevOps world. That's the modern day approach to how applications are developed, operated, deployed, run, etc. On that path has been the embracing of microservices. That's the ravioli model, right? The architecture. Then we've also adopted containers as the technology to enable us to use DevOps with a microservices architecture. And finally, embracing all of this in the cloud gives us the dynamic ability to use a whole bunch of different aspects of different hardware in different forms. So if you look at this from a Red Hat technology stack point of view, it's a bit hard to read here, but all of our applications, our products are built in a way that helps you to enable this. Right from the top, embracing DevOps, going through microservices, using some of our newest technology like the mobile platform, and the ability to use all middleware, which creates applications in a containerized form, and then embracing that with the containers on Red Hat Enterprise Atomic Platform, and finally using that across all the basics of the public cloud, the private cloud, the virtual, and the physical. So this really comes into our overall picture, which is Red Hat Open Hybrid Cloud. We want to make sure that you're able to use those containers that you've built across all 4 footprints. Now this is a very important concept, because if you have the portability and you have the way of taking your containers from one platform to another, one footprint to another, you can actually move them very quickly and dynamically from physical to virtual, private, and public. And if you have that ability to move them dynamically, including the notion of spinning up these containers within seconds, you have the ability to take advantage of all the hardware at your disposal for the best way to deploy your application. But underneath all of this is Red Hat storage. And that's where we need to make sure that the containerized application, different from the traditional application, takes advantage of storage in the right way. So this is where we bring on the whole concept of software-defined storage, SDS. And this is really a realization that developers want to be able to control their requests for storage in their applications. But operations don't want to have the headache of making specific allocations for each different application or each different developer. So we've moved from a proprietary hardware model where each vendor was creating specific storage hardware, single purpose, right? You bought it, you plugged it in, it worked one way and it only did one thing. We've moved from that to commoditized hardware. Now we can use any hardware, including hyper-converged hardware, where we can use things that are just simply off the shelf, and you can customize how that's used. A very important point here is that this goes from hardware-based intelligence to software-based intelligence. Now, what do we mean by that? It means that you can actually dictate, after the fact, how you want the storage to be used. There's a concept that's been employed in the latest version of Ceph called erasure coding. Has anyone heard of that? It's a very smart technology, erasure coding. And what that does is it breaks up a piece of data, an object that needs to be stored, into many, many parts. Think of like a puzzle. It breaks it up into many parts. And it spreads those parts across multiple different storage places. But the brilliant part of it is that if you lose just one or two parts, it's okay. You can reconstruct the object from the beginning. So it's a way of actively saving your data in a distributed fashion, but without having to make multiple copies every time of the data. So we talk about having 2 copies, 3 copies, 4 copies of the data. With erasure coding, you get this amazing concept of being able to store a piece of data 1.75 times or 1.6 times, depending on the level of the erasure coding, which gives you more efficient use of your hardware, but it's all software defined. So we're employing software intelligence to decide how we store our objects. Another very important concept is this tiering concept. So we have data that's different levels. We have hot data that needs to be accessed rapidly all the time, and then you have cold data. Take, for instance, a bank that's recording conversations with their customers. After 6 months, 1 year, 2 years, it's not likely that we're going to need that data. So we can store it cold. We can archive it, right? But you can put a policy in place that says when the data becomes 6 months old, or when the data is more than 2 years old or a certain size, I want you to move it to the cheaper storage. So you have different levels of storage that cost different amounts of money. You've seen a lot of talk about these very dynamic flash and SSD drives and high-performance computers. That's wonderful stuff. But it's not necessary to store all of your data at that level. You can store some of it at a less expensive level. And finally, the point about SDS is that it's an open development. Just like our software, like Red Hat is completely 100% open source, so the use of software-defined storage is also open. We don't close our development cycles so that everyone can view and contribute and see how we are deploying software and storage and use those technologies in ways that you want to fine-tune them. It's a very open model. So I'm going to finish now with 2 final examples, a little bit more technical, about how you might use this in the containerized application architecture. Bearing in mind what I've said before about using containers in a ravioli, right? That's the microservices approach to architecture. So in this case, using Kubernetes or using an orchestrator, you can actually deploy a whole bunch of applications in containers with their own local storage. But that local storage is provided by Red Hat Ceph. So because Ceph storage is able to provide lots of small pieces of storage rather than one big piece of storage, we can actually create lots of redundant block storages to each one of the containers, which reduces the effect of losing one of those containers. If you've distributed your application, think of like a swarm of bees, right? You have thousands of bees going around collecting pollen. If one of the bees doesn't come home and he misses, it's okay. The rest of the bees will survive. But if you only had one bee and you had all the pollen collecting here and he got lost, then you're in trouble, right? So you've got this swarm approach where you've got lots and lots of bees going out there, lots and lots of containers. Now that's not to say that every time that stores something, it has to store it locally on the container, because that is ephemeral. That's a word that means it's not going to last a long time, right? If that container disappears, you lose the local data on that container. However, you can use things like S3 compatible APIs to use the Ceph as an object store, so you can store things off container. That's a good consideration, right? You're actually taking the data, making sure that it's persisted because it's outside the container. Then if you switch the container off, leave it, or create more containers, it doesn't affect the application data as a whole. The other model that we're looking at is, this is becoming more and more popular to think about, is the hyper-converged model, where you actually spin up hundreds, maybe thousands of containers, each one of them with their own storage container software. So think of something like Gluster, where you have a file system that requires lots of parallel access to the same file, shared file system. Many of those containers at the bottom can be created very quickly, each with its own local storage, but shared amongst the group storage, which enables all the containers above the application to access all of the containers below, all the storage containers. And that's a way that you can dynamically create that. And again, getting back to this, that it enables the developer to architect this, to design this in his code, so that when the code is deployed, it's all automatic and it creates the entire application in its deployment, in its shape, like this. I hope this has been helpful. I will be outside if anyone would like to ask any questions, but I hope this has been a good forum for you and appreciate it. Kamsahamnida. Thanks for attending.